Okay, good morning to everyone. In the previous class, we were discussing about the importance of dissolved oxygen that is present in water and how exactly it is going to affect the uh, aquatic life as well as the uh, water supply distribution network or water treatment process. So we'll go ahead with the organic matter. See, the organic matter, you can say it is the the dead plant which undergo decomposition after some time. Dead plants, whatever it is there, sometimes it will go under decomposition. Suppose if you throw any of the waste food into the water body, after some time it will go under decomposition. If I say it is organic, so I said it is the dead plants are the food. So if I am classing this as organic, the main classification is always the carbon content. If carbon content is there or if C is there in that uh, the either waste food or the plants, so then I can say it is a organic. Then what it will do in the aquatic systems or the water system? Suppose if I throw the waste food or the dead plants into the water body. So what exactly, what mechanism is going to happen inside the water body? Slowly what will happen is that it will go under decomposition. If I say it is a decomposition, it is one biological activity or it is the biological activity. So if biological activity means it is due to some of the microbes or the bacteria, due to bacteria or due to some of the microbes. Then what these bacteria or microbes will do? These bacteria and microbes, they will eat this as a food. Whatever the food is there, it will eat that as a food. For example, if the dead plants are there, that dead plants will be utilized by all these microbes, and all these microbes, they will use it along with, because this requires also oxygen for the respiration. They will take the waste food of the dead plants as a food. Along with that, it will consume, or the microbes will consume the dissolved oxygen that is present in the water also, and it will multiply its growth, multiply its growth. Means we already know that the bacterial growth curve. So what these bacteria will eat this dead plants as a food, then it will decrease. Along with that, it will consume the oxygen that is present in the water and multiply its growth. Means now we can link in this way. This formula we can write. So if food is there, then if more food or if more organic matter is there, which is equivalent to the organic matter, then which is responsible for decreasing the dissolved oxygen and increasing its the bacteria, increasing its bacteria. It means that if more organic matter is there, there will be 100% decrease in the dissolved oxygen and increasing the bacterial. We don't know what kind of bacteria are there, whether it's a beneficial, non-beneficial. If you take in the water body, most of the things are non-beneficial only. We can call it as if you take 100% bacteria, in that 99% are non-beneficial. 1% it may they are beneficial to the human beings, but once this is happening, so not it is not good for the aquatic systems, because we say that the sufficient dissolved oxygen should be there in the water, minimum 4 to 5 milligram per liter we have to maintain. So if more food is there, then which is equivalent to the organic matter, then which is responsible for decreasing the dissolved oxygen and increasing the bacteria. So this is irreversible to the environment. Then whatever this one is there, organic matter, it is equivalent to, I can say it is the POD. If more food is there in the aquatic system, or if more organic matter is there, there will be increase in the BOD. Then what is exactly this BOD is? So then BOD is the amount of dissolved oxygen needed by the aerobic biological organism in a body of water to break down the organic material present in the given water sample at a certain temperature or a specific time period. So, whatever I have explained uh, in detail in this way, it is the same meaning. Now, so I say that the amount of dissolved oxygen is needed. So then we can say that the amount of oxygen is consumed by the bacteria. Only you have to concentrate on the aerobic bacteria. We have three types of bacteria. So the first one, that is the aerobic, then anaerobic, anaerobic, and one more is it is survive in both aerobic as well as anaerobic conditions. So we require in this POD process only the aerobic biological organisms or the aerobic bacteria. So when the aerobic bacteria are there, it is going to multiply its uh, growth. Maybe today, if it is there, um, two are there. Tomorrow, it is going to become 8. Then again, it is 16. Like that, it will grow by using the oxygen that is present in water, and it will break down the organic material. Whatever the food is there, it is going to break. This food material is there, it is going to break. By breaking this food, then what will happen? It will grow. Then automatically there will be a decrease in the dissolved oxygen. As the growth of the bacteria will grow, so then automatically that bacteria are required for uh, because each requires the separate oxygen, automatically it will consume. Then um, even it will requires also some of the temperature we have to maintain, and in certain temperature only there will be some bacteria are going to be active, and it is going to break down the food materials. Then if I say that now, I can define the whole thing in this way. If food is there, the BOD is high, then which is equivalent to the more organic matter, then there will be 100% depletion in the dissolved oxygen, then there will be increase in the bacteria. So then uh, this experiment has to be conducted in the laboratory. Whatever I am talking about this BOD, Means if BOD is high, if BOD is more, then I can say that the water is polluted. Means if more organic matter, more BOD, then it is more polluted. Then we have to decrease this BOD. Then norms, if you go to the CPCP standards for the disposal of any of the wastewater from any of the industries, it give the guidelines like 30 milligram per liter we have to maintain. Below 30 milligram per liter we have to maintain. Then we have to dispose. If you conduct the BOD test for the wastewater sample, then it has to come below 30 milligram per liter. Then only we have to dispose it. Then this test has to be conducted in the laboratory for either for the 3 days. We'll conduct either 5 days or 7 days, or sometimes we'll go with 11 days, or sometimes we'll go with the 20 days. Means minimum 3 days are required to find out this BOD test. Why? Because it is the BOD itself is the aerobic process, or it is to microbial process. Always the microbial process is a slow process. It is the slow process. If I give you two bacteria with 1 kg of any of the food, so it won't eat that much in a fraction of seconds or fraction of. It will take its own time to break down that the whatever the kg of organic matter is there. So then it is a slow process. That is why always minimum it requires 3 days. Why I'm going with the 3 days means, why not go with the 5 days or 7 days? Minimum it is 3 days, because 60 to 70% of the activity, bacterial activity, it is going to happen within 3 days. Then up to 5 days you can expect 80%. Then till 20 days, till 28 days, uh, up to 95 to 98% of the organic matter will be broken down. You just imagine 60 to 70% it is going to consume within 3 days. Then after that, another 10% in a 5 days. You can say it is 80%. Then another 15 days, 5 to 20 days, it is 15 days. In the 15 days, you just imagine it is taking 15 days to uh, complete up to 95 to 98. Still, like I cannot say it is 100%. Even sometimes it will take 50 to 60 days to complete this process, because the bacteria are having its own priorities. Um, like first it will eat the carbonaceous organic matter. There are two types of organic matter. One is carbonaceous, and one more is nitrogenous. Within the first 1 or 2 days it will eat the carbonaceous organic matter. Carbonaceous means which consist of carbon in their food. Nitrogen means it is the second priority. Means if the carbon that food is over, it will, some of the bacteria it will prefer another in the next days, that is from 3 days to 5 days. So this will be uh, more priority for the pathogens or the bacteria. First it will eat this one, then it will decrease the deworm. The second, it will eat the nitrogenous organic matter and it will decrease the deworm. So this is how, if I give you a rice and the apple, normally you prefer the apple than the rice, because it's a more priority. So like that, the similar way, the bacteria are having its own priorities. First, it will eat the carbonaceous organic matter, and second, it will it as an heterogeneous organic matter. So and this is it is not exactly the precise quantitative test, although it is widely used in an indication of the organic quality of the water. I already said that there are some differences it will be there because the bacterial activity will go on changing as the time progresses and depends on the activity. We will see how exactly this is not that much accurate compared to any of the test. Uh, this BOD value is most commonly expressed in milligram of oxygen consumed per liter of sample during 5 days of incubation at 20 degrees centigrade and is often used in a robust surrogate of the degree of organic pollutants in the water. This I already discussed. Why we are considering 3 days? It does not mean that 5 days or 3 days. You can conduct it for the other days also. It depends on what accuracy you want. Then the very important thing is that they have mentioned here the 20 degree centigrade. Why they are considering it as a 20 degree centigrade? See, while in in our countries normally we'll maintain it for 35 degrees centigrade for this test. But in other north, if you go to some of the cold countries, they will maintain it as and 20 degrees centigrade. Normally, it on an average of 20 degrees centigrade. But in our country, we'll maintain it as 35 degrees centigrade because it is more feasible in as in practical way in most of the regions. 35 degrees centigrade is most visible for most of the bacterial growth. Even if you decrease the temperature, the bacterial activity will not happen. Once the bacterial activity will not happen, means there will be an there will not be any breakdown of any of the organic materials. So this is related to the organic matter with respect to the BOD. So BOD5 is an normally I will write phi it stands for will write the BOD5 in this way, not we will write BOD5 like this. Means it is a 5 days. We are keeping the sample in the BOD incubator. Normally for this experiment we will use the BOD incubator. BOD incubator. And is we'll keep all the samples for 5 days. Then after 5 days, the formula is for BOD, that is BOD5, DO initial the first day, DO final, uh, this divided by dilution factor. So this dilution factor we will discuss in the next class how exactly it is going to affect while measuring the BOD. What is this BOD incubator? Is BOD incubator we are maintaining the constant temperature. What I said is that is 35 degrees centigrade in that uh, uh, instrument, so that the bacteria has to grow and it has to be and whatever the oxygen. Normally we will go with the first day, that is the DO initial. We'll find out it. Then the DO final we'll find out it after 5 days. The experiment protocol is there to find out this. Then we'll keep the sample in the incubator. We will maintain the constant at 35 degrees centigrade. In that bottle, whatever the bacteria will be there and the organic matter it will be there. The bacteria will eat the organic matter as a food and it will decrease the dissolved oxygen is present in the water. Then once that is happened, that activity has happened, then um, we will take it the sample and we'll analyze the final DO. Then we'll find out that there will be a decrease in the dissolved oxygen. Once it is decreased, then how much it is decreased, based on that we'll find out the BOD. Then the remaining things we will discuss in the next class. Thank you.